Hello everyone, welcome back to the AAS YouTube channel, and this one is going to be on the series about meeting your scientific editors and your lead editors. And I am delighted today to have Michael Endl with us, who is the lead editor. He's also a scientific editor for the Corridor, the solar system, exoplanets, and astrobiology. Hi Michael.
Hello.
How you doing today?
I'm fine.
How's your Zoomiverse these days?
Yes. Every day I enter the Zoomiverse, and at the end of the day I come out again, pop out, and back to life in quarantine. Social distancing.
There we go. Are there planets in your Zoomiverse?
Yes, they're virtual exoplanets floating around. Yeah.
Hot and cold ones. Cool. So why don't you tell us, what do you do for research?
So I'm at the University of Texas at Austin.
Okay.
And I'm using primarily the telescopes at McDonald Observatory to study exoplanets. So I'm doing this primarily for detection. At least at the beginning, I was doing a lot of detection work to find planets when this was still kind of the interesting part. But nowadays, of course, we have moved on in the field, and we are far more interested in characterizing planets, and of course to establish the big global statistics of what kind of planets are out there. So I'm doing a lot of observations with measuring precise radio velocities to get masses of exoplanets. Okay. But I also dabble into like atmospheres, transmission spectroscopy, and I'm working with a lot of targets coming down from the space mission. So I was heavily involved in the NASA Kepler mission. Then later a little bit also in K2, and nowadays we're doing a lot of observations of test targets, obviously. And where I'm coming from, well, as everybody can hear, I'm not a true Texan. I was born and raised in Austria, hence the Arnold Schwarzenegger accent. And I got my PhD at the University of Vienna in 2001, and started as a postdoc at UT Austin in 2001. I'm here since then.
So how did you, I'm curious, how people get into the fields they do, right? So how did you get into exoplanets as opposed to cosmic ray background or something like that?
That is kind of a little bit of a funny story, because when I was doing my master's thesis in Vienna, nobody worked on exoplanets. That was actually at the time, I started my master's thesis before the time of 51 Pec. The very first solar type exoplanet around the solar type star was not yet detected. So I started actually my astronomy career as working in X-ray astronomy. Huh? And I was using a German satellite called ROSAT to study the corona of an active star. Okay. And my advisor in Vienna was actually an optical spectroscopist, ground-based observations. So he needed somebody who understood X-ray data. And he had a friend and colleague in Germany who was working actually for the ROSAT project. So he sent me there and for a visit to reduce and analyze the data. And that was Martin Kürster at the Max Planck Institute. And and Martin and I, we got together, and at that point he already told me about this little side project that he had together with people from Texas, working using a telescope in the southern hemisphere at ESO, at the European Southern Observatory, to search for planets. Okay. At when no planets were found yet. And I was always interested in this. There was just no way to work on this really. But Martin and I turned out to be, we talked more about exoplanets back then than about the X-ray data. It was kind of boring in comparison. And then the first exoplanets were discovered. Martin moved to Chile, to ESO, and encouraged me to apply for a PhD fellowship, which was a little bit unusual because at that time Austria was not part of ESO. But I tried anyway, and I got it. and then spent my next 2.5 years in Chile, working with Martin on a PhD for spectroscopic detection of exoplanets. And we were kind of lucky because back then in 1999, we stumbled across, so I did first working on an analysis method to improve the precision of the data, which until then they had already started years and years earlier to collect data, but they didn't get the precision to detect planets. And then I came in, did that new method, and then boom, the first planet popped out of the data, and it was the very first exoplanet in the habitable zone of a sun-like star. It was still a gas giant because back then we didn't have the precision to detect lower mass planets, but it was kind of a big deal, and it was, I think, the 16th exoplanet or something like this discovered. And
that is awesome.
And through this connection, this project was also started by astronomers from Texas with Martin. Through this connection, I learned about a postdoc position that Bill Cochran here at Texas offered at the time when I finished. I applied and I got it. And that's how I got here.
Wow. So do you speak Spanish?
I speak Spanish, but my Spanish is really crappy nowadays because it's more or less replaced by a little less crappy Portuguese because my wife is Brazilian. So I've spent my past, many years more in Brazil, talking Portuguese. And whenever I try to speak Spanish, then it gives me a hard time because it's replaced by Portuguese words.
Yeah.
Similar, but it's not the same.
Awesome. Cool. Do you still get down to do observations in Chile?
No, it's amazing. I mean, it's horrible because since I got to the US, I have never been back to Chile. And I would really love to go back and see how everything changed and even visit La Silla Observatory where I spent many, many, many nights. Yeah. That would be great, but I hadn't had the chance yet.
May it be in your future.
Yeah.
Speaking of the
future, go to the Southern Hemisphere though, many times, not only visiting Brazil, but also professionally. I was lucky enough to have a project in New Zealand. So even further south than La Silla, we were at Mount John University Observatory, which is in the South Island of New Zealand, at a project to search for Earth-like planets around Alpha Centauri, and that was also very, very nice.
Speaking of the future, as you sort of look at all the manuscripts that are submitted down your corridor, what do you sort of see on the horizon for the field of exoplanets? You kind of mentioned we're sort of in the era of characterization, right, as opposed to finding, number 4,227. Yeah. Unless it happens to be Earth 2.0, then that's pretty interesting. Yeah. So what do you just sort of globally, what's your take on what you see in the, let's say on 5-year, 10-year horizon, if you want?
So 5-year horizon, I think we will do a very similar thing that was done with Kepler. Kepler looked there in unprecedented detail. First of all, it discovered all these small planets and how big that population really is. But even better, we were able to characterize the radius distribution. And people found something very interesting about the radii of small planets. But one dimension was missing. That was the mass dimension. And I think primarily also due to tests and other programs, we will add the mass dimension in the next maybe 5 years to this study and understand the zoo of smaller worlds, from mini Neptunes to super Earths to real Earth analogs much better. Okay. But what is absolutely clear on the horizon in 10 years maybe is that we will do atmospheric characterization for these small planets. I have the feeling that really everybody, well, although it's not always mentioned, really everybody is keen to try the hand on to look for biosignatures around habitable planets that are potentially Earth-like. And I hope that I will see that still in my lifetime, that we will have a list of like 10 or so planets where each one of them has kind of a probability assigned to it by astronomers whether life exists on those planets or not.
Mm-hmm. Very cool. Yeah, one of the things strikes me is people taking global circulation models that were, of course, originally developed for Earth,
Yeah.
And then now they have a whole new arena to play in, which is exoplanets. So.
Exactly, and that's basically one branch that has just exploded recently in my corridor. There's like a large number of papers that come in that are submitted studying the various different interior geological processes, but also the atmospheric circulation models, just expanded and extended to the exoplanets that we see out there.
It's very cool. Very cool. So I'll start broad and then I'll narrow it down a little bit. So the broad question is, what is your history with the AAS journals? And so let's narrow that a little bit by, what was your first APJ paper or letter? And when did you start becoming a lead editor?
So I have to think about the first question, because originally, since I was in Austria and at ESO, I kind of published in astronomy and astrophysics in ANA. But once I moved to the US, I started publishing in HA and APJ, and I'm really hard pressed now to think back and
That's okay. I just
it was probably a paper on. So when I got to Texas, I immediately started planet search program, looking for planets around the really low mass stars, the M dwarfs. This was kind of an unexplored region at that point of time, and I probably published a paper on my M dwarf program. It's the first paper either in HA or APJ. I don't remember now.
Okay.
But how I got how I became a scientific editor, that I remember very clearly, because that was just a few years ago. Actually, just I think 3 years ago.
4 years.
4 years, yeah. That was again just happenstance. I was maybe at the right place at the right time. Chris Sneeden, professor at UT, who was the former editor for the APJ letters, sent out an email to all the exoplanet people in our department, which were many, it was just a handful, that AAS journals are looking for scientific editors specialized in the exoplanet field. And I said, there you go. I want to do this, send it back. And that's how I became a scientific editor first. And then I think 2 years ago, when the previous lead editor stepped down, I became the lead editor for this course.
Cool. So sort of a somewhat personal question, but I'm always interested, because the responses vary widely, is why would you want to be a scientific editor, right? Yeah. What was the driver for you?
I think the driver for me was to try something new.
Okay.
To try something fresh and new that I have never tried before in my career. And it's basically the same motivation that I had when I started teaching, because I had never taught before. And then I started, okay, let me try how I like teaching. And I did the same with the editorial process, and I enjoy it because it's really keeping me, at the forefront of my field.
Yeah.
Which is really nice. And I'm actually getting to know my community much more than I was able before. It's really great. Yeah.
Cool. And vice versa.
Yeah.
You get to do a little bit more.
Maybe many people regret to have met me at because I usually immediately say, this is a good person I can ask them next time to review a paper. So they get an email a week after the conference.
Yeah.
Request.
Oh God, I met that guy.
Oh my God, I should never have talked to this guy.
No, he's gonna hit me up for stuff. No. Yeah, I know what most people are pretty good. So speaking of, just put a number on it for folks. Roughly how many new submissions do you get coming down the solar system exoplanet astrobio corridor?
Very stochastic. there was one week that was incredible. There were over 20 papers submitted in just a single week within the stretch of 3-4 days. But on general, I would say it's more like of the order of maybe 10 papers a week.
Okay, 520 a year, 500 a year.
And something like this.
Okay. And so what do you think, makes for a good, solid submission manuscript, right? So
I have not encountered what I would not call a solid submission. There was not, I think I've never had a paper that I immediately rejected without review.
Okay.
Only for other reasons, not for reasons of like that it was just not scientifically compelling.
Okay.
Sometimes I talk to authors about that they can maybe improve the paper in other aspects, but I think I don't need to give the community any advice because they know how to submit solid papers. Yeah.
Okay, cool. How about on the other side of the coin, referees? Do you have any tips or guidance that you would like to share? What makes a good referee report, or what makes a good referee?
A good referee is thorough, understands the topic obviously, but this is also part of my responsibility since we have to find really experts in the field as reviewers, not only somebody who says, "Yep, well, I'll do it." Of course, timeliness is a big factor that we editors like. We don't like to have to remind people 5 times that the report is due. Now, of course, we're in a special situation, so now we are far more generous in our deadlines. But what I have to say about referees, which was the single most surprising fact for me once I became an editor, is I was surprised how difficult it is to find reviewers that accept the task. So, when I was giving when I obtained a request to review a paper prior to me being an editor, I usually said yes because I thought this is, if I not review another paper at the same time, I said always yes because I thought this is my duty as science, right?
Yep.
This is part of the scientific process.
Yep.
Maybe duty is a strong word, but I kind of said, okay, this is part of my job. And I was very surprised to see how difficult it is actually to people to accept this task. So maybe something that a message to the authors is maybe, and to the referees, of course, also, that it takes surprisingly sometimes long to find a reviewer. So don't bear with the journals. Don't expect necessarily a referee report on your table 3 weeks after submission, because there's sometimes a pretty long time until you get somebody to review it.
Right. Don't confuse that 3-week optimal period with when you submitted it.
I mean, it does happen, and we find usually a reviewer within a few days, but sometimes it's very hard.
Yeah, particularly if there's a lot of authors on a paper, think LIGO.
Yes, but everybody in that field is basically
in the fields on a paper, like, oh my goodness. And it can also, on the other end, it can also be really hard if it's a very small field and there's only a handful of experts in the world. Those can be hard to find as well. And sometimes it's just hard because people have proposals due. It's proposal season. It's observing season, wherever it may be. So sometimes, it can.
And now, of course, we are even in a more special situation. People are staying at home, have to stay at home.
Yeah, I find it's kind of a mixed bag on mine. On the one hand, people are home, and so now some of them have more time to do stuff, either their papers or review other papers. And on the other side, then there's people who just have too much going on at home, on the home front, and they can't do it. So for me, it's been kind of a mixed bag on availability of referees.
That's absolutely true. I mean, people have now, many people are, when they're at home, they also have to deal with their families, and especially parents. Kids are not in school, so it's very demanding, and I fully understand when right now some people just say, I cannot do it, I cannot do it at the moment.
Agreed. So, is there anything else that you would like to share with our authors and non-authors out there?
Yes, please.
Editorial process or anything else?
Please submit your papers to my corridor.
Oh, love it, love it. Well, I look forward to having some X-ray exoplanets. So
yeah, well, we actually have. I mean, there's at least papers submitted about radio emission from hot Jupiters with a magnetic field.
Decameter. Yeah. Absolutely. Cool. All right, that'll do. Michael, I want to thank you so much for sharing some of your time today and chatting about the solar system exoplanets and Astrobio corridor.
Thank you.
Thank you. We'll see you, everyone. Bye-bye.
Bye-bye.